Good afternoon.
Dang it, I was so close.
How are you guys doing?
Oh, pretty good. Pretty good.
Good to hear. All right, let's see. Who are we? All right, so let's see. We've got one, two. Oh, I'm kind of blocking the way here. All right. Yeah, so the default that it shows me and it covers up Denon, so I never quite know if he's here or not. So glad you're here. So your surgery went okay?
Yeah, I guess.
Yeah. So now what did you have done to your shoulder? Or was it
So it was my wrist. I broke it last year playing football, and something went wrong. Like it grew at an angle. So I had to get it rebroken, and then bone graft put in, and then like a plate and like 12 screws or something like that.
That sounds painful just hearing it. So anyway, well, I'm glad you're back. I know when I had after I broke my fractured my fibula last year, it was kind of funny because I came back and I was still on some. I did it on Saturday. Let's see, and so I tried to teach on like Tuesday, and I with the pain relievers because they gave me some pretty good pain relievers, and I could not do calculus. I could not do calculus on those. I could probably do like college algebra or trig or whatever, but I could not do calculus. I remember a student asking me, how do you do this problem? And I'm like, I knew how to do that last week, but I had no idea. It's like my brain just wouldn't work. So I learned that you kind of have to be at your game. So anyway, so I was on Tylenol for a while. Tylenol didn't affect it, but I mean those powerful pain relievers, those will get you. So anyway, I'm glad you're here.
Yeah, I mean, yesterday was pretty bad. I only came to school for college. But.
So are you on some pretty heavy duty pain relievers?
I was, but I've been trying to like lay off of them.
Yeah.
So I just take like ibuprofen and stuff.
Yeah.
But yesterday I just didn't it hurt super bad, so I just didn't feel good, and then so I just came to college. So.
Well, I know that like for me, pretty much all I use it for after a while was just after a few days was just to sleep, because every time I would turn over, my ankle would just kill me, and so if I could get enough sleep, I would be okay. So I hope you're sleeping well on that. That's kind of tough. But I guess you take your sling off and everything. So
yeah, it's still hard.
Yeah,
it's like awkward, and then I always will fall asleep pretty easy, but I'll move and like hit it against something, and then I'll wake up.
Yeah. Well, I hope you keep healing well. That's a tough one, because when something's hurt like that, you realize that you had no idea how often you used it, or something like that. But anyway, I appreciate you being back. I know that is tough after, major surgery, and you only missed like one day of school, right?
Yeah, only one day.
See, that's pretty awesome. That's pretty awesome. So anyway, sometimes just being here is good, even if you can't. If you're not into it, just showing up is a big battle. So I appreciate that. So anyway, well, let's go ahead and talk about. So today we're in the middle of 3.7, which is implicit differentiation. We were on this slide right here. Okay, the 3 steps to implicit differentiation that we went through. So I don't know if I can't remember if you wrote that down or whatever, but anyway, got that. That's where it says steps for implicit differentiation. And so we'll finish that, and then we'll start in on related rates. Now, we've only got 2 sections left in chapter 3. And so I anticipate that we'll probably be finishing this either this week or the first part of next week. And then what we'll do is have the chapter 3 tests, and then we'll have the midterm. That's kind of the plan right now. So we'll just kind of, as we get closer to finishing this, we'll kind of set the dates and all that kind of stuff. But I just want you to know that's what's on the horizon here. But the other thing that's on the horizon is actually one of my favorite days is coming up, because I have a day where when you come to class that day, it's going to make you smarter for the rest of your life. Okay? So I'm excited about that day coming up. Anyway, so we'll see. That'll probably be Monday of next week, maybe Tuesday. Just depending. I don't know. I'll let you know a day ahead what day is going to make you smarter. So, all right. Well, let's go through this. Any questions or comments or concerns before we get started?
Are we taking quizzes tomorrow?
Yes. So, thank you. The quizzes tomorrow will be 3.3, 3.4, and 3.5. Okay. All right. So, yeah, 3.3, 3.4, and 3.5. All right. So let's go through this here and. All right. So the steps for implicit differentiation. And we went through this yesterday, but we're just kind of going through it again. So differentiate both sides of the equation with respect to x, treating y as a differentiable function of x. So then whenever you take a derivative that has y's in it, you're going to have a dy dx, like the chain rule. Collect the terms with dy dx on one side of the equation. Solve for dy dx by factoring and canceling. Okay, so that's kind of what we did yesterday. All right, were there any questions on any of this? Okay. All right, so now what we're going to do today is go to finding a second derivative implicitly. So to take the implicit differentiation can also be used to take the second derivative. Now, the trick here is that you take the first derivative just like we did yesterday, and then you're going to use the first derivative in your answer to the second derivative. Okay? So it's a little bit different than what we've done, but you'll see it's not too bad. Okay. So here it says find. Okay, now this is, again, the second derivative, or I could put y double prime. But d2y over dx2 is take the second derivative. Okay, so we do it term by term. So you say the derivative here would be 6x squared, and then you can put the dx in there if you want. Minus, okay, the derivative of 3y squared would be 6y, and then you got to remember the dy dx. And then the derivative of any constant is 0. All right, so now we solve for dy dx by moving the terms that don't have dy dx to the other side, and then dividing by the whatever's in front of the dy dx, so negative 6y in this case. And so here the negatives cancel, the 6's cancel, and so you get dy dx is x squared over y. Okay, so that part was like yesterday. Okay, now this next part is new. Okay, so watch this part carefully. So when we go to take the second derivative, so we just say, okay, taking the derivative of this is the y double prime, or d2y over dx2. So here we're going to have to use the quotient rule. So we say that start with the denominator times the derivative of the numerator, 2x, and again you can put in the dx if you want. Okay, minus the derivative of the numerator, or excuse me, minus the numerator, which is x squared, times the derivative of the denominator, which is 1 dy dx, all over the denominator squared. Okay? Now you might be thinking, wait, that's not new. We've done the quotient rule. Okay, but this is the part that's new. Okay? See, we want the second derivative just in terms of x and y. We don't want it in terms, we don't want to have the first derivative as part of our answer to the second derivative. So what we do is, in place of this dy dx here, we substitute what dy dx is in terms of x and y. So in place of dy dx here, I'm going to plug in x squared over y. Okay? So I get y times 2x, or 2xy, minus x squared times. So in place of dy dx, I put x squared y over y squared. Okay, now the problem here is the algebra. Okay, in algebra, in algebraic fractions, see, we don't want to have a complex fraction in our final answer. Okay, so what we do is, to get rid of this little y here, because that's what's making this a complex fraction, what I do is multiply both numerator and denominator by y. Okay? Now when I simplify that, I'll get 2x y times y is y squared, minus, okay, x squared times x squared is x to the fourth, and then this y cancels out that one. So I don't have a complex fraction anymore. And then in the denominator, I have y cubed. So now this is okay for a final answer, but a lot of times what the book will do, and I just want to make sure that you can do this too, is if you have a monomial denominator, they'll separate the fraction and then reduce each one as possible. So here, y squared over y cubed is just y, so you get 2x over y minus x to the fourth over y cubed. You can't do anything to that one. So either of these answers would be fine. Okay? All right, so questions before I have you do one. All right, so let's see how you do. So go ahead and do practice 4, I guess. I'll leave this up for a minute. All right, so Skylar, when you have dy dx, let us know. So just the first derivative.
X over y squared.
X over y squared. That's correct. Good job. Any questions so far? Okay. All right, so Jordan, when you got the final answer then.
Alright, so I got y squared minus 2ix divided by y squared.
All right. Well, let's see. That's not what I got. So let's see what's going on. All right. So you get x over y squared as your first derivative. So the second derivative, you start with the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, which is 2y dy dx. So times x. All over the denominator squared, which would be y to the fourth. So then you replace the dy dx with x over y squared. So that gives you y squared minus 2x squared. And then here, y over y squared cancels, leaving you with just y over y to the fourth. And so then to clear out the y's, the y here, you multiply numerator and denominator by y. And so then you get y cubed minus 2x squared, y's cancel here, over y to the fifth. And then if you split it and simplify, you get 1 over y squared minus 2x squared y to the fifth. So somehow I think maybe you didn't cancel this y with the y squared here. That's what I think.
Yeah, that's what I did. So I went down, and because I skipped that, I multiplied the equation by y squared divided by y squared instead of y divided by y.
Which would actually be okay if at the end then you could actually factor out a y and cancel it. So I mean it wouldn't be the worst thing in the world to do that, but you'd have to simplify a little bit more at the end. Okay? All right, any other questions on that? All right. Okay, so the next part is we're talking about a normal line. All right, now you remember the slope is the derivative is the slope of the tangent. Okay, that's one of our definitions of the derivative. Well, a normal line is a line that's perpendicular to the tangent line. Okay? So, I probably asked this before, but have any of you taken physics? In physics? No? Yes? No? Well, in physics, they have what they call the normal force. And the normal force is the force that's perpendicular to the ground. Okay? And so it's the same idea, is that the normal line is perpendicular to the tangent line. So if you imagine the tangent line being like the surface, the normal line is coming right through. Okay? So if in this equation, if this is your tangent line through a point, then the normal is what's perpendicular to it. Okay? So if you're ever asked to find the normal line, it's just like one little algebra step different than finding the tangent line. You're still going to find the derivative. Okay? All right. So first it says to show that a point lies on an implicitly defined function, plug it in. You plug in the x and the y, and you want to make sure that if you're trying to find a normal or a tangent through a point, a lot of times you want to just double check and make sure that point is in fact on the line, on the curve. Okay? All right. So this says show that the point 2, 4 lies on the curve x cubed plus y cubed minus 9xy equals 0. Then find the tangent and the normal there. Okay? All right, so first, to show that the point lies on the curve, you plug in 2 for x and 4 for y. So you'll have 2 cubed plus 4 cubed minus 9 times 2 times 4. You want to see, is that equal to 0? So that would be 8 plus 64 minus 72 equals 0. So you get 0 equals 0. So that checks. So that means the point is in fact on the line. Okay? You get it to work. All right, now to find the tangent and the normal, for both of these we're going to first need the derivative. Because the slope of the tangent is the derivative. So now we do what we've been doing here with the implicitly defined functions. And we say, okay, the derivative of x cubed is 3x squared dx dx. Plus the derivative of y cubed is 3y squared dy dx. And then for this one right here, we need to use the product rule. So negative 9 dx dx times y plus negative 9x times 1 dy dx. So I use the product rule to get these two terms. And then the derivative of 0 is 0. All right, now I get the dy dx terms on one side, so I'm going to leave them on the left, and then move the other terms that don't have a dy dx to the right. Factor out a dy dx, and I have 3y squared from this term minus 9x. And so now I divide each side by that. 3y squared minus 9x. And so then that is the derivative. So what I did here is I factored out a 3 and canceled it. All right, now, so that's the slope at any point. So now to find the slope at the given point, I have to plug in both the x and the y. So that's different. We haven't done that too many times. So we're going to plug in 2 for x and 4 for y. And I guess that's on the other page. All right, so plugging in 2 for x and 4 for y. Uh-oh, there we go. Okay, here we go. So I get negative 2, the negative of 2 squared plus 3 times 4 over 4 squared minus 3 times 2. So that's negative 4 plus 12 over 16 minus 6. So that's 8/10, which reduces to 4/5. So that means so that's the slope of the tangent at that point. So then the equation of the tangent is y minus the y coordinate equals m, the slope, times x minus the x coordinate. Okay? So we've done that before. Now, so to get the equation of the normal, what's the only thing that's going to be different?
Would you flip the m because it's, I forget the word, but it's like the flipped of the...
It's actually the opposite reciprocal. So you flip it and change the sign. Okay? So it's the opposite reciprocal. So, but the point is still the same. So the equation of the normal is still going to be y minus 4, still going to have the x minus 2. What's different is the slope, instead of being 4/5, you flip it and change the sign to negative 5/4. Okay? So you find the derivative to get the slope anywhere. Then you plug in the point to find the slope at that point. Then you'd use the point slope formula to find the equation of the tangent. Then you take the opposite reciprocal slope to get the equation of the normal. Okay? All right, so go ahead and try that for practice 5. Okay, so Hannah W, what's the derivative? What's dy dx?
Can you repeat that real quick? Sorry.
What's dy dx? What's the derivative, the slope of the tangent? At any point.
I don't know if this is right, but I got negative 3x squared plus 4.5y all over 3y squared minus 4.5x.
Okay. Okay. So I think that's what this is the same thing as what you said. It's just written in a different order, but it's equivalent, right? Okay. All right. So that's the derivative at any point. Any questions on that? Would anyone like me to go through that, calculating the derivative? All right. So, Denon, what's the slope of the tangent at that point, that given point 1, 2? So if you plug 1 in for x and 2 in for y into the derivative, then what do you get?
I need some help.
Okay, so did you get to here? Okay.
Yeah.
Okay, so if you just plug in 1 for x and 2 for y, then see you get 4.5 times 2 minus 3 times 1 squared over 3 times 2 squared minus 4.5 times 1. And so then when you simplify all that, you get 4/5 or 0.8. Okay? So that's the slope of the tangent at that point. Okay? All right, so
How does it simplify from 6 over 7.5 to 4 over 5?
well, see, you can't leave this as your answer because you can't have a decimal inside a fraction. So if you multiply top and bottom by 10, then you'd get 60 over 75, and then you could divide 15 into both of those.
Okay, thank you.
Okay. Now, the other thing that you could do, if you're with the calculator, you could do it this way. Let's see. Okay. See, if with the calculator, you could do 6 divided by 7.5. And then, because normally we want slopes and fractions. And so then the 0.8, you just hit the math key and then answer as a fraction. And so then you could get 4/5 that way too. Okay. All right. Now, so 4/5. So then the equation of the tangent would be next. So, David, what's the equation of the tangent? What is it?
Hang on, I'm still finding it.
Oh, okay, no problem. And Joey, I have to say I appreciate you dressing up for my class, adding a little bit of, class to the class, so to speak.
You're welcome.
So is it y minus 2 equals 4 over 5 times x minus 1?
Yep. So that's the equation of the tangent. Okay, and then finally the equation of the normal. Chloe.
Y minus 2 equals negative 5 over 4 times x minus 1.
That's it. Great job. Okay, any questions on any of that? Or any questions on anything from 3.7? Okay, so let me just, before we do the introduction to 3.8, and that's all I'm going to really do today, is just a little intro to it. But I want to make sure about the quizzes. Okay, so 3.3, 3.4, and 3.5 quizzes tomorrow. And then, so St. John's and Mogion will take those from 150 to 250, with the exception of Jorn and Hannah W. will take it at 10:15. And then Winslow, you want it when? When would you like me to set up the quiz?
Miss Lopez emailed you just during this class. Could we do it in the morning at 8:30?
Yeah, sure. Okay, and so so everybody else we're good, or do we need to make any other adjustments? Okay, beautiful. Okay, well let me just kind of show you what's next. What's next is kind of an application section where most of the problems are like word problems. And so they're called related rates. And I really enjoy this section because you really start to see the power of calculus in all of the myriad applications. So like you'll do one problem from physics, another problem from medicine, another problem from geometry, another problem from sports analytics. Okay, I mean it's really cool how the different types of problems where you can use calculus to help solve answers. By the way, do you guys know the word analytics? Do you know what I'm talking about when I say that word? No? Does anybody know what analytics are? Basically, the way I remember it is it's using math and statistics to analyze something. So analyze with statistics, analytics. And so there was a movie that came out a few years ago about how they use it in baseball. And it's called Moneyball. Have any of you seen Moneyball? Well, anyway, so basically how they use math and statistics to figure out how to beat the Yankees. That was the idea of it. And But anyway, I was watching, what was it? Sunday Night Football or something? I can't remember. A football game the other day. And they were showing that the Indianapolis Colts had hired 2 full-time guys just for analytics. And so they were figuring out, like, okay, if it's 4th and 1 and you're against this team, should you go for it or punt? And then if you go for it, which play is more likely to win against this defense? Anyway, and so it was just fascinating to me how more and more applications of this you find. And so in related rates, it says some problems ask for the rate at which a variable changes. In each case, the rate is a derivative with respect to some variable. And most of the time in this section, the variable is going to be t. It's going to be with respect to time. So you're going to look at how this changes with respect to time. You know, like like there's one where, let's say a cop car is chasing some robbers, right? They've just done a bank heist, and the cop's coming from this direction, and there's a right angle, and then these bad guys are going off in this direction. What's the rate of change of the distance between them? You know, how is that? Is the cop closing? Are the robbers getting away? I mean, there's just some interesting things there that we'll discuss. Okay? Even things like area equals length times width. Okay? I mean, you think, well, that's a pretty basic formula, but what we're going to do tomorrow is we're going to analyze how things change with time. So like let's say on a computer, if you grab the corner and, you're changing the length, the width, the area, the perimeter, all of those things are changing. And so it could be a function of time. And so what we'll do is say, we're going to take the derivative of this with respect to time. So the derivative of A is d A dt, and then for this we'll use the product rule, okay? And so we're going to have some of that kind of stuff, all right? Okay, let's actually stop right there, okay? And I'll give you an example, and then we'll start in it for real tomorrow. So anyway, well, thanks, you guys. Have a great day. Good luck on your quizzes, and we'll see you tomorrow.